In this video, I'll be showing you how to solve some partial differential equations using separation of variables. In this video, I'll be referring to partial differential equations as PDEs. So that stands for partial differential equations. Just as a shorthand, so I don't have to say partial differential equations every time, I'll just refer to it as a PDE. And if I refer to an ordinary differential equation, I'll refer to it as an ODE. Alright, so let's just get started. Let's just do a basic introduction of what a PDE is. So a PDE is a differential equation that basically includes partial derivatives. So a partial derivative will look like this. You'll have this notation, while an ordinary differential equation, or an ODE, will have this notation pretty much. So the only difference is, instead of using a D, we use this symbol here. Okay. So what's the difference between an ODE and a PDE? So let's just take a look. So a PDE is used when you have a function that has two variables as an input to get an output. So you have u of x and y, so you need an x and a y coordinate here, so these things here, an x and a y coordinate, to produce a third coordinate. So if you have a function with two variables, it will create a surface. With whether you have a function of one variable, it will create just a curve. Okay, so let's say we have this particular curve, so we have 2x y squared, and you wanted to find the partial derivative with respect to x. So when you find a partial derivative, you treat the other variable as a constant. So all I'm doing is I'm just treating y squared as a constant, and I'm just differentiating with respect to x. So partial derivative of u with respect to x is just going to be equal to 2y squared. Okay. So this here that we've found here, this is a PDE. So basically, we want to find in this video is we're going to given something like this, and we want to find a general solution to a function, pretty much. Alright, so let's get straight into it. Alright, so let's just go down to the very first question. Alright, so this is the PDE that we'll be solving for equation 1. The partial derivative of u with respect to y is equal to y times the partial derivative of u with respect to x. Find the general solution for u of x and y given the partial differential equation above. So if you want to have so it will be using separation of variables for this question. I don't know if I spelled variables right, but it doesn't really matter. This is a math video, not an English video. So if you want to have a go at this question, feel free to pause the video and have a go. Alright, so the way we solve this with separation of variables is we assume that a function of u and a function of u, x and y, is the product of f of x times g of y. So what does this mean? We're assuming that u of x and y is a product of a function of x and a function of y. We have to make this assumption, and basically what we do is we pull a bunch of information from this to basically solve our PDE. Because if we didn't make this assumption, and we couldn't really pull any information from this, it's too hard. So we make this assumption. So assume f u of x has this form here. Okay. So what we're going to do now is basically we're going to find our components that we have in here. So we need to find the partial derivative of u with respect to y and the partial derivative of u with respect to x. So what we're going to do here is we're going to differentiate this expression here so we have our derivatives pretty much. So what we do here is we go the partial derivative of u with respect to x. We take the partial derivative of f of x times by g of y. Okay. So that's going to be equal to partial derivative of u with respect to x is going to be equal to, so g of y is not effective because y is treated as a constant when you're taking the partial derivative with respect to x. However, this is a function of x, so we have to diff this. So just in notation terms, partial derivative of u with respect to x is equal to f prime of x times by g of y. So notice how this didn't change, it just remains constant. However, if let's say we didn't have this here and we took the partial derivative with respect to x here, this would turn to 0 because it's just a constant and we're differing a constant. However, since we have this function here, this just basically means derivative. I'm not going to write derivative, I'll just say derivative. This basically means just derivative. Okay, so that's how we got our first thing here, right? So, and now we've got to find the partial derivative of u with respect to y. So if we want to find partial derivative of u with respect to y, take the partial derivative of u of f of x and g of y. So we're going to have partial derivative of u with respect to y. It's going to be equal to f of x. F of x doesn't change because it's a constant, times by g prime of y. So that means this is the differential of g of y. Okay. Cool. Alright. I'm gonna rub this out because it's a bit gross looking, and I'm just gonna make all this a bit smaller so we have enough room to continue our solution to this PDE. Right. Boom. That looks a lot nicer as well. Alright, so now what we're going to do is write out our PDE that we have up here. So we have partial derivative of u with respect to y is equal to y times the partial derivative of u with respect to x. Basically, we're going to plug in our stuff we have here into there and our stuff we have here into there. Okay? So that's the second step, right? So we're just going to do that real quickly. So partial derivative of u with respect to y is equal to f of x times by g prime of y. So the first derivative of g of y, is equal to y times by f prime of x. So the first derivative of f of x times by, oh, my keyboard got in the way, f of x times by g of y. Alright, so everyone sees how I've gone from the first step to the second step. All I've done is put this stuff into this PDE, and I've basically just simplified it down to here. Okay. Alright, cool. Alright, so what we're going to do now is basically we're going to get all of our functions of x and our functions of y on one side. So we want one side with x and one side with y. Okay. So just to make things easier, I'm going to make this the x side and this the y side. Right. So I want to get my f prime of x over to this side, and I want to get my g prime of y onto this side. Okay. So what we're going to do that is basically, excuse me. Basically, we're going to divide both sides by f prime of x and g prime of y. Okay. Because if we do this, we're moving both things across at the same time and cancelling the thing on the other side. So if I do this, g prime of y is going to cancel on this side, and if I do this, f prime of x on this side is going to cancel. And by doing that, we have this whole side in terms of x and this whole side in terms of y. Right? So rewriting that, we have f of x divided by f prime of x is equal to y g of y divided by g prime of y. Okay, coolio. So we have x and y separated. That's fantastic. Now, for this to be true, well, if we just take a look at both of these, this left-hand side is just some function of x. Okay. Because it's just the function of x divided by its derivative, that'll just be equal to some other function of x, okay? And this side is just some function of y. Now for them both to be equal, for this to be true, they both must be equal to a constant, okay? So using this idea that they're both equal to a constant, we can break this up into two ODEs, two ordinary differential equations, okay? So they're both equal to some constant, I'll just label it C. So we can break this up so we can have f of x divided by f prime of x is equal to C, and we have y, g of y, divided by g prime of y is equal to another constant C. So by doing this and knowing this certain fact, we have two ordinary differential equations with just two variables, okay? We've made it a lot easier on ourselves. And now we can solve both of these via integration and separation of variables, okay? I hope that made a bit of sense. If you're a bit confused, leave a question in the comments. So I'm gonna move just this thing here. Oh, it's not wanting me to select. So I'm just gonna move this down a bit. And I'm just gonna move this, if it would let me select it. I'm gonna move this just down a bit. I'm gonna move this here. I'm gonna make this all smaller. So if you want, you can take notes when I finish the problem. Alright, so first off, I'm just going to move this ODE to the side. I'm going to solve this one first. Okay? So first off, C is a constant. F of x is a function, and f prime of x is the derivative of f of x, which is another function. So all I'm going to do, first off, to solve this is I'm just going to move f prime of x up here. Okay? So by doing that, I'm multiplying both sides by f prime of x. So I'm left with f of x on this side is equal to c, a constant, times by f prime of x. Okay. Now we can simplify. We're going to simplify this a lot by changing the notation of how this looks. So just changing the notation, f, which is a function, is equal to a constant times by the change in f over the change in x. So you see how I've changed from this to that function notation? The reason I've done this is we can apply separation of variables to ODEs. So we can integrate with respect to f, and we can integrate with respect to x to make this a lot easier, right? So what I'm going to do now is basically I'm going to get my f with my d of x. So I'm going to get this with that, and I'm going to get this with just the constant here, okay? So how am I going to do that? First of all, I'm going to multiply both sides by d of x. So I'm left with f d of x is equal to c d of f. And I'm just going to divide both sides by c and f. Okay? So I'm left with dx over c is equal to df over f. Okay? Now, since our c is a constant, 1 over c is just going to be equal to another constant. Okay? So applying this knowledge here, we can change how the left-hand side looks. So instead of having dx over c, we can rewrite it as just c times dx. Just knowing, because we originally had dx over c here, but 1 over c, which is this here, because there's a 1 here, is just another constant. So applying this, we can make it look like that, just to make it simpler when we integrate, okay? So that's all I've done there. Because you might be thinking, oh, you've used your algebra a bit wrong, but no, I've applied that and that knowledge, knowing that 1 over c is just going to be equal to another constant. It won't be the same constant, but it'll still be a constant. So this could be constant 1, and we had our original constant here just equal to constant 1. So that's all I've done there. Okay? Right, if you want a bigger explanation on that, just leave something in the comments. Alright, cool. So what we're going to do now is we've got our dx on this side with a constant, and we've got df on this side with our f. All we're going to do now is integrate both sides. So integrate c with dx and integrate df with f. Okay? So left-hand side is just going to be cx plus another constant d. And the right-hand side is just going to be the natural log of f plus another constant q. Alright, so I'm just going to simplify things. I'm going to move my q to this side. So I'm just going to have natural log of f is equal to c of x plus d minus q. I'm going to change this and let this whole thing be h, because this whole thing will be equal to another constant. So rubbing that out, just going to have plus h. And now all I'm going to do is apply the idea, since the natural log is equal to log base e, all I'm going to do is get f by itself, and there's a h there. So f is equal to e to the cx plus h, right? So that's our using a log law, and I've actually run out a bit of room. So I'll just write this down here. So I'll go f is equal to e cx plus h. Now recall, using our index laws, am plus n is equal to am times a to the n. So I'm going to break this up. So f is equal to e to the h times by e to the cx. Okay? Now this whole thing is going to be another constant, so we're just going to let e to the h equal a, where a belongs to any number. Okay? Cool. So using that idea, move that. Oh, whoopsie daisy, I brought down up the second question. I'm just going to move that down. Pretend you didn't see anything. Hold up. This is lagging a bit. This is our second PD we'll be solving. It's a lot harder than the first one. Alright, so applying that knowledge, we just have f is equal to a e to the cx. So therefore f of x is just equal to a e to the cx. Boom! We've solved our first ODE here. So we've solved the equation f of x divided by f prime of x is equal to c. We've solved that ODE. So all I'm going to do now is just make all of this a bit smaller, because we still got to solve, we still have to solve our second ODE. So make this a bit smaller. If it loads, sorry, my computer is lagging a bit. Make that a bit, okay, it didn't select properly. Alright, cool, got it all. Make that a bit smaller. And move that there. Alright, cool. And we'll just rewrite our working we've done here. So simplifying that, f of x is equal to a e to the cx. Alright, cool. Rubbing all this out. We still got to solve our second ODE. We haven't even finished the first question, and we're already 17 minutes into the video. Alright, so now we got to solve this boy here, our second ODE. So I'm just going to rewrite that as y g to... Sorry, my computer's not doing that great. I'm just going to rewrite it down here so it's, I think it's, yeah. So y g to the y over g prime of y. Alright, cool. This is equal to a constant. Right, so this is our second ODE, right? Because we want to find u of x and y, but we made the assumption that f of x is equal to f of x times g of y. So we found this, we need to find that now, okay? So all we got to do is just solve this ODE here. So I'm just going to bring this up here, okay? So doing that, I'm just going to multiply both sides by g prime of y. So y, g of y, is equal to g prime of y times a constant. Now I'm going to change the notation, so I'm going to have y times g is equal to dg over dy times c. So all I'm going to do now is going to get all my dg with my g. So I'm going to get this with that and this with that. Okay? Cool. Alright, so what I'm going to do, I'm going to move pretty much this up here by timesing both sides by dy. So I have y dg dy is equal to c dg. I'm going to divide both sides by g. Okay? So I'm left with y dy equals c dg over g. Okay. I'm going to move my c to the other side just to make things a bit easier. So I'll divide both sides by c. And of course, 1 over c is just going to be equal to another constant. I'll just say that's k. So it's equal to ky dy equals dg over g. Okay? So if you're a bit confused by this, I just did that with the other ODE up here. Okay? Alright, so now we have this here. Right? So what are we going to do now? Basically, we're just going to integrate both sides. So the left-hand side is just going to be ky squared over 2 plus some constant d. The right-hand side is going to be natural log of g plus some constant h. Okay. Alright, now I'm just going to move my constant to the left-hand side. So I'm going to have natural log of g equal ky squared over 2 plus d minus h. This whole thing is going to be equal to another constant. Let's just call that q for arbitrary sake. So natural log of g is equal to ky squared plus q. Going to apply our log law. So g is equal to e to the ky squared plus q. Therefore, using our index laws, we're going to have a constant at the front here and get rid of our q. So therefore, g of y is equal to some constant b e to the ky squared. Okay? Boom. That's our second ODE solved. So all I'm going to do now is all we got to do now to solve our partial differential equation is plug in f of x here into here and g of y into here. So therefore, u of x and y is equal to a e to the c x times by g of y, which is b e to the ky squared. Okay? Alright. You'd notice these are like, so basically we can add the terms up here. So we can simplify this going u to the x, y is equal to a times b e to the cx plus ky squared. Okay? And this here is just going to be equal to another constant. Let's just say a times b is equal to h. Therefore, I'm just going to rub this out here, run out of room. Therefore, u of x and y is going to be equal to h e to the cx plus ky squared. And that, ladies and gentlemen, is our solution to this, if the computer loads, it's lagging a bit, is the solution to this PDE. Okay? Boom! That is question 1 done. Let's move on to the next one. If you notice, that used a lot of algebra and calculus and a lot of critical thinking. I'm just going to have a sip of my tea. Alright, so that was a pretty standard separation of variables using ODEs and to solve a PDE, which is a partial differential equation. Let's move on to the next example here. This is the one we will be trying to solve next. Okay, this one's a bit harder than the first one. So before I get this started, I'm just going to make sure I have enough room to complete all the algebra and calculus I'll perform. Okay, so find the general solution for u of x and y given the PD above. So I want you to, using separation of variables, I want you to find u of x and y for this partial differential equation. So feel free to pause the video and have a go at it. Alright, so first off, make the assumption, assume u of x and y is going to be the product of a function of x and a function of y. Okay? We're going to stick with f of x and g of y just to make things a lot easier for you to understand from the first problem. So, obviously, looking at our PDE, we need to find the partial derivative of u with respect to x and the partial derivative of u with respect to y. So we're going to apply some derivatives to this expression here, our arbitrary expression of our answer. So partial derivative of u with respect to x is equal to partial derivative of x of f of x and g of y. Okay. So therefore, partial derivative of u, partial derivative of u with respect to x is going to be equal to f prime of x times by g of y. G of y isn't effective because it shares a constant when you use a partial derivative of x on it, but f of x is effective, of course, and differentiates to f prime of x, which is our notation for the first derivative of f of x. Now we got to find partial derivative of u with respect to y. So, oops, what the heck happened there? This computer is lagging. Too much hardcore math. Jesus. Alright, so partial derivative of u with respect to y. Take the partial derivative of y of this arbitrary expression here. So f of x and g of y. So we're left with partial derivative of u with respect to y is equal to f of x multiplied by g prime of y. Okay, so f of x isn't effective because we're taking the partial derivative of y, so therefore x is a constant, therefore any function of x is treated as a constant, but our functions of y, that is a terrible looking y, of course differentiates, so we use g prime of y to indicate our notation for the first derivative of g of y, pretty much. Okay, so we found our derivatives that are in our PDE, so all we're going to do, I'm just going to make this a bit smaller so we have enough room. That's where the computer lags when I do this stuff. I'm just going to move this up here. Boom. Alright, so let's just rewrite our PDE. So our PDE is x times y times the partial derivative of u with respect to x is equal to y times u plus the partial derivative of u with respect to y. Okay? We have this and we have that. We also have our u, which is up here. Okay, so we're just going to plug in this stuff into here and the rest into its corresponding spots. So I'm just going to rewrite this entire thing here, except with these in their corresponding spots, okay? So let's rewrite our PDE with our expressions that we've established up there. So x times y times the partial derivative of u with respect to x is f prime of x times g of y equals y times u, and our u is f of x times g of y plus the partial derivative of u with respect to y, which is which is f of x times g prime of y. What happened down here? Get out of here. Okay, so can everyone see what I did there? So I basically just substituted this into there, this into there, and this into there. So that's how I went from this line here to this line here. Okay? Alright, cool. Hopefully you understood that. It was just a substitution. Yeah. If you have any questions, leave them in the comments. I'd only be watching this video if you have some experience or taking a course on PDEs. If you just watch this out of nowhere, you'd be probably very lost. So I'm making normal math videos, physics problems, and of course I'm starting to make some university math level videos. So I haven't made any videos on this stuff in the past, so this is the first video, but I just put it out there for anyone that's like Googling how to solve this stuff. I pretty much just make any video I want, pretty much, and I stick to certain topics. So this is the first topic of advanced calculus, solving PDEs using separation of variables. Okay? Alright, so what we're going to do now, we want to get a function of x on this side and a function of y on this side, okay? So what we're going to do, looking at the right hand side, we can see we have an f of x here and an f of x there. That means we can factor out f of x on the right hand side. So x, y, f dash of x times g of y is equal to, we can take out f of x multiplied by y, g of y, plus g prime of y times that self. So if I distribute this into each of them, I'll get this line up here. Okay? Cool. I'm going to divide both sides by f of x. So that will get rid of that on this side. So moving the stuff up here, we'll have x times y times f prime of x over g of y divided by f of x is equal to y g of y plus g prime of y. Okay? Now we just want to get our y and our g of y onto this side. So we're going to divide both sides by y and g of y on both sides. So y and g of y. So we'll cancel here, and we're left with a function of x on the left hand side and a function of y on the right hand side. So just simplifying that, we're going to have x of f prime of x divided by f of x is equal to y g of y plus g prime of y over y g of y. Okay? So taking a look what we've just done, we have an entire function of x on this side and an entire function of y on this side. Right? Just looking at our stuff here, we can see that this is the same as that, so we're just going to simplify the right hand side a bit. So we're just going to divide out y and g of y. So I'll just write out the left hand side first. F is just going to be equal to, so if I divide, I'm just going to apply this to that and that, so we're going to have y, if it loads, my computer's lagging a bit, if we have y g of y divided by y g of y plus g prime of y over y g of y. Okay, this whole thing is going to simplify to 1, and this whole thing's just going to stay like that. Okay, so rubbing this out, I'm going to replace that with a 1. Alright, and now we've simplified both sides. Make that proper g. Alright, cool. So taking a look at this. Alright, so for this to be true, this side and this side must be equal to a constant. Okay? So now we can break this up into two ODEs. So we'll break it up into x times f prime of x over f of x equals a constant c and 1 plus g prime of y over y g of y is equal to another constant. So this is our first ODE and our second ODE. Okay? We'll solve the first ODE first because that's the simpler one, and we'll just get that out the way. So let's rewrite it. Let's actually make all this a bit smaller so I don't have to go to the next page just yet. Hold up, we've got to take our time with this because our computer is not very strong. Alright, cool. Got that all selected, just make that a bit smaller. Boom. Alright, so if you want to take any notes, feel free to do so. Let's just get started with this ODE here. So we have x of f prime of x divided by f of x is equal to some constant. Okay? I'm just going to move f of x up onto the other side just to make it look a bit nicer. So we're left with x f prime of x is equal to our constant c. If my computer, it's frozen just a bit, just bear with me for a second. Alright. So it's equal to f of x times c. Alright, now we're just going to change the notation of this. So we're going to have x times df over dx is equal to f times c. Okay. So we want to get our df with our f and our dx with our x. Except we want the dx on top. So all I'm going to do is I'm just going to multiply both sides by dx. Okay. Actually, I'll just move this down here. So I'll go x df dx equals f of c. And of course, c is a constant. So it'd actually be proper to write the c in front of the function. So c of f. Okay. Multiply both sides by d of x. So x df equals c of f dx. Okay. Because if I multiplied this side by d of x, it would cancel here. So that's why it's not on this side anymore. Alright. Now I'm going to divide this side by x, and I'm going to divide this side, actually I'll divide both sides by f and x. Okay, so it will cancel here, and the x will cancel here. So we're left with df over f is equal to c dx over x. Okay. Cool. What we're going to do now, pretty much we're just going to integrate now. So we'll just go the integral of this and the integral of that. Left hand side is going to be natural log of f plus a constant, let's go q. And this is going to be c natural log of x plus another constant, let's say h. Right, I'm just going to simplify the right hand sides and left hand side. So just moving my q across, I have natural log of f is equal to c natural log of x plus h minus q. This will be equal to some constant. So I'm just going to replace that with some arbitrary letter alpha. Okay. I'm going to apply my log laws here. So if you have a constant in front of log of x, that is the same as log of, whoops, my computer's lagging, sorry, again, whoopsie daisy. That's the same as natural log of x to the a, okay? So applying that log law to this spot here, I'll have log of f equal to log of x to the c plus alpha. I'm going to move my logs to the other side. So I'm going to have log of f minus log of x to the c equals alpha. If you have log of x minus log of, let's say, a, that's the same as log as x divided by a. So applying that log law to this side here. Whoopsie daisy. Just gonna rub that out. So left with log of f over x to the c equals alpha. Now we know that log is equal to natural log of e, so we're just going to exponential this. So simplifying this, we're going to have f of x to the c is equal to e to the alpha, right? I multiply both sides by x to the c. So therefore, f is equal to, hold on, the computer's lagging again, sorry guys. X to the c times by e to the alpha. This whole thing is going to be a constant. We'll just say that's a. So therefore, f of x is equal to a x to the c. Alright, that's our first ODE solved, and that was the I wouldn't say it was the easiest one to solve, but it was pretty difficult still. Alright, I'm going to make this all a bit smaller, so if you want to copy any of this down. So all I did was solve our first ODE, so our working starts up here, and then it finishes down there. Alright, so all I'm going to do is going to make all this super duper small, so I have enough room to complete the second ODE. The reason why my computer lags is because it's just it gets overheating when I'm writing on it, and yeah, it just overheats. So that's why it just takes sometimes as the videos go on, my writing gets a bit slower. It's not because I'm getting slow with the math. It's because the computer isn't allowing me to write as quickly as I want it to. Okay. Whoopsie daisy, what did I just do there? Oh, I think I got that from somewhere. Don't remember where though. Yep, that's all good. Alright, move this, just this, if it will allow me to. Sorry guys. I'm just going to see if I can start solving it on its own. Alright, so our second ODE is up here. So our second ODE is 1 plus, what is it? G prime. Oh no, our computer's lagged out a bit. I don't know if I'm going to be able to finish the problem. Hopefully, if it loads and stops being like this. Okay, there we go. Alright, cool. So let's just see if we can simplify. Write it out. So I'm just going to write on a bit of paper so I don't have to scroll down. Prime of y and y gy equals c. Alright, cool. Got it now. Let's start solving it. So our second ODE is 1 plus g of y prime divided by y g of y is equal to a constant. So this is our second ODE, okay? All I'm going to do is get rid of this 1. I'm going to minus it on this side and minus it on this side. So that goes to bye-bye, pretty much. If it will allow me to rub out. Okay, it's not letting me rub out, so I'm just going to simplify. So g prime of y over y g of y is equal to c minus 1. That's just going to be equal to another constant, so I'm just going to say that's k. Okay. I'm going to move all this up here, so I'm going to have g prime of y is equal to k y, that's a y, not g. Oh, whoops. So I'm going to have g prime of y equal to y gy of k. Okay. Change the notation, so this is dg over dy equals to y times g times k. All I'm going to do is multiply both sides by dy, so I'm going to have dg equals y g k dy, and divide both sides by g, so I'm going to have dg, that's a g over g, equals k y dy. Integrate both sides, natural log of g plus some constant q equals k y squared over 2 plus some constant h. Simplifying that. Do you have any room to finish this? What is going on with my writing? It's like moved all my stuff. So I'm just going to start writing it here. So natural log of g is equal to ky squared over 2 h minus q, that's just going to be another constant. I'll just say that's capital H. Exponentiate that, so gy is e ky squared over 2 plus h, and of course simplifying that, gy is equal to d e ky squared over 2. So all I did was change this constant to a constant here. Okay, So that's all I did. So therefore, we have f of x and we have g of y. So u of x and y is equal to axc times by d e k y squared over 2. Okay, and that's pretty much the solution to our PDE up here. Okay. Oh jeez. Sorry, my computer's lagging a lot right now. So that's the solution to our second PDE. I'm going to end the video here. Sorry it was lagging so much. It's because the computer's overheating. If you have any questions, please leave some in the comments. Thank you for watching.